Alright, so here we have to find a method to find the greatest term in terms of magnitude of the binomial expansion of a plus b power n. So suppose that we find the greatest term somehow, and it is this term. You have n choose r, and then you have a power n minus r and b power r. And we know, because this is the greatest term in terms of magnitude, this is going to be strictly uh, bigger than or equal to, I should say, n choose r plus 1, and then you got a power n minus r plus 1, so it's going to be n minus r minus 1, and b choose r plus 1. Okay, and this is also going to be bigger than or equal to n choose, okay, let's just write it over here. So n choose r, a power n minus r, b power r, this is bigger than or equal to n choose r minus 1, a power n minus r plus 1, and b power, I think, r minus 1. Cool. So now let's deal with these inequalities first of all. So let's look at the first one. So that's going to give me like n choose r upon, no, maybe I should do it like this. So it's going to give me a power 1, okay, upon b, that's going to be bigger than or equal to n choose r plus 1 upon n choose r. And we know we have a kind of like formula for this, so like a upon p should be bigger than or, and like, by the way, I should inform you that over here we are taking a and b to be like magnitude, so I should actually put mod a and mod b over there, but just put a minus over there, and now you will get what I want to do. Okay, so you will have a upon b is like bigger than or equal to, where was I, n choose r plus 1 upon n choose r. So we have a formula for that, which is n minus r plus 1 upon r, and for here, like, the value of r is r plus 1, so it's going to be upon r plus 1 and n minus r. And then similarly you will have I think b upon a, yeah, that looks correct. So b upon a is it's like bigger than or equal to n choose r minus 1 upon n choose r. That's okay. Okay, so yeah, that's correct. You do have b upon a over there, which is bigger than or equal to n choose r minus 1 upon n choose r, which is like the reciprocal of our formula. So it's going to be r upon n minus r plus 1. So let's take the reciprocal of this inequality. So we will get a upon b is less than or equal to n minus r plus 1 upon r. All right, that looks good. Yeah, but could we do something else maybe? No, I don't think so. So yeah, that should kind of work, but let's see what we can do. It's like a upon b minus 1 is less than or equal to n plus 1 upon r maybe. All right, so how is that helping? We want to have something like that over here. Let's just try solving for r over here. So let's take this inequality as well, and let's try to change it somehow. So maybe like let's add 1 on both sides, so that will give me a upon b plus 1 is bigger than or equal to n upon r plus 1. No, wait a second, n plus 1 upon r plus 1. Okay, so now let's take the reciprocal of both these inequalities. So that's going to give me like n plus 1 upon r is, I think, less than or equal to, so it's going to be less than or equal to 1 upon this stuff, which is like b upon a minus b. Yeah, that looks correct, so that's nice. And yeah, that is correct. So like, maybe I can divide this by n plus 1 right away. So yeah, oh sorry, it's supposed to be plus 1 over there. Yeah, that's more like it. So yeah, you should in fact be having a plus 1 over there, because over here you're going to get a minus 1, and then that goes on the other side, it comes plus 1. So that's nice, right? So over here you should instead have a plus b. Okay, and then similarly we can flip the other inequality which we got, which is that I think this one. Okay, so we have to flip this, right? So it's going to be r plus 1 upon n plus 1, right? Yeah, that looks, wait a second, is this going to be less than or equal to or bigger than or equal to? Where was I? Oh yeah, it's going to be bigger than or equal to, because we kind of flipped it, right? So it's like bigger than or equal to this thing, and then we can flip this inequality. So you will get r upon n plus 1, that is less than or equal to, so it's like less than or equal to b upon a plus b. Okay, that's nice. So let us see, maybe we can multiply by n plus 1 over there. So like r plus 1 should be bigger than or equal to n plus 1 times this thing, so like b upon a plus b. And similarly you should have r is less than or equal to n plus 1 times b upon a plus b. So I'm just going to call this thing as something, say m. So we will get the following, that r is less than or equal to m, but at the same time r is bigger than or equal to m minus 1, where this m stuff is given by this thing. So n plus 1 into b upon a plus b, where I should say that here b and a and b, like these things are actually magnitudes, but never mind that. So yeah, that's nice. So now we know how to find for what value of r we should get some kind of like greatest term in terms of magnitude. So I hope you enjoyed the video, and I will see you in the next one.